into practice and see if we can do a much harder problem. This one is 3 to the 9th power, all multiplied by x squared times y. All of that is raised to the negative 2. Then all of that is being divided by 3 to the 3rd times x to the negative 4 times y. One thing I want to point out with this one is that when you're applying the rules, you do have a little bit of freedom on which ones you do first. So experiment with trying the rules in a different order and see if you can come up with the same answer. As long as you apply the rules carefully and correctly, it should work out just fine. Alright, so what shall we do with this one? Well, I'm going to go ahead and take that negative 2 and spread it out over my x squared and y, since both of those are being multiplied on the inside there. So 3 to the 9th, then I'll have an x squared to the negative 2. Alright, and I'll also have a y raised to the negative 2 as well. So I put that negative 2 on both of them. Now let's go ahead and multiply our exponents here. So 3 to the 9th, then 2 times the negative 2 would be x to the negative 4, y to the negative 2. Alright, looks good. Let's see, where can I go from here? Well, I like dealing with those negative exponents and really changing the location of things so I don't have to worry about negatives. So let's do that first. Everywhere I see a negative exponent, that part will change its location. So I'm going to leave the 3 to the 9th for now. I'm going to leave my 3 to the 3rd power. And let's take care of this one. So x to the negative 4 will be x to the 4th in the bottom. This one, which is x to the negative 4, now let's put that in the top. Y to the negative 2 is in the bottom. And this y already has a positive exponent, so no need to change that one. All right, continuing on, let's see what else we can do. These 3's out here, they have exactly the same base. So I can subtract their exponents, 9 minus 3. And I can do the exact same thing with these x's. Subtract their exponents. Let's see, what should I do with those y's on the bottom? Well, they have the same base, so I will add those exponents together. Good way to start crunching things down. So this will be 3 to the 6th power, x to the 0 power, all over y cubed, or y to the 3rd. Okay, getting there. 3 to the 6th power, that'd be 729. X to the 0 power, remember that's one of our special ones, is 1, all over y to the 3rd. So this one crunches down quite a bit, but in the end we're left with 729 all over y cubed. And then we don't have anything else to combine, and so we will consider this one simplified. All right, only one more to do. This one we want to make an expression that represents the area of a figure. So I wanted something that was a little bit more like a word problem, or at least something that we'd have to draw it out of. And you'll see we'll use our rules along the way to crunch this down. So when I look at the area of a rectangle like this, it's formed by taking the width of that rectangle and multiplying it by the length. Now I'm not really sure what the width and the length here, since both of them are written as expressions. So I'll write those in. So area is the width for x squared, and the length is 8x to the 4th. Okay? That means I can really take this expression for the area and put it together using some of my rules. Let's rearrange it out. So I'm going to put my numbers, 4 and the 8 together, and my variables with exponents together. So 4 times 8, 32. And then I have x squared and x to the 4th. So I can do these by adding them together since they have the same base, giving me x to the 6th. So this expression would really equal the area of the rectangle. Right, that's quite a lot of rules to absorb, but again, with a little bit of extra practice, they should become a little bit more familiar. Watch for those special ones like raising something to the 0 power so that you know that that is always 1. Thank you for watching Educator.com.